Hi everyone, thank you for joining me. I'd like to introduce you to a new Office feature called Storm of the Month. This is developed by the Severe Weather team and is geared towards showing you all interesting events that occurred over the last month. So for this case, we're going to be discussing the April 27th event. So first off, I would like to show you the analyzed maps from the top-down view for this system. So I'm going to show you the 12Z images on the left and the 0Z on the right. And as you can see, we do have a trough moving across the Great Basin into the desert southwest, with a jet stream moving into our area with west-southwest flow. In the 500 millibar map, you can see it's fairly stacked in itself, especially by the 0Z time frame. We still see that westerly to west-southwest flow over our area. And another feature to note is a shortwave. So you can see it a little bit here in the 12Z map, but then it becomes more pronounced by the time you get to 0Z. And this is going to remain fairly stationary just off the Rockies for most of this event. And then around the 0Z time frame, that does begin to shift into our area. Looking at the 700 millibar layer, again, you still see that trough hanging out over the southwest and a little bit more moisture over our forecast area. Again, you can really see that shortwave fairly well. Alright, so looking at the 850 millibar map, you can see a surface low hanging out around the high plains, both in the 12Z and 0Z time frame. Another area to note is that shortwave trough. You can see it a little bit better in the 0Z frame, still hanging out off the Rockies. There's also this frontal boundary along Cheyenne and Kit Carson counties here around the 0Z time. And that frontal boundary actually moved across the area. It moved south during the morning hours and then slowly tried to progress north as more of a warm front. It did take it several hours to kind of move north, and it did stall out just south of I-70 for most of the afternoon. So from there, I want to discuss the SPC mesoscale parameters. So looking here, I'm going to show you from 21Z to 4Z time frame. So this map's going to show you the 21Z on the left and 22 on the right, and then progress onwards through there. So this map is your 850 millibar heights and temperatures and dew points. So you can still see that shortwave trough pretty well at 21Z, just kind of hanging out off the front range. And then that frontal boundary, which I mentioned earlier, still hanging out around Kit Carson, Cheyenne counties. And that does remain in this area over the next couple of hours. Again, you can see this here as we look at the 23Z and 0Z time frame. Remains somewhat stationary as we move through. Looking at the 1Z hour, we are starting to shift a little bit more to the east. And then you start to see our gradient weaken just a little bit as this starts to move east to the northeast. Looking at our surface to 3 kilometer shear, I like to think of this as a high shear, low cape example, and you'll see why here in a little bit as we look at the cape. But looking at the shear, you do see that southwest flow across much of our area from the north, and then a little bit south of I-70 you start to see a little bit more of an upslope flow. Over eastern Colorado, we do have that southerly flow, and that is going to play a role with our storm motions, which you'll see in a little bit when I talk about the radar. You do see we have a 40 knot shear max right along the Kit Carson, Sherman County area, and that boundary will still remain stationary along with the front over the next several hours. By the time we get to the 22Z time frame, 23Z, we are seeing shear increase. So here we have a 60 knot max moving into our area, and then that shear max is going to continue further east into our northwest Kansas counties, and then kind of move a little bit more to the northeast as this event progresses across our area. Next, looking at the mixed layer CAPE and SIN, this is using the 100 millibar plots. You can see a nice CAPE max right ahead of that frontal boundary there. So we have 1,000 joules here at the 21Z, and then 1,800 by 22Z, and again that remains somewhat stationary. As we start to move into the late afternoon or late evening hours and we start to lose that heating, you do start to see that cap move back in as our SIN builds up, and then our CAPE continues to decrease as this event moves more into our northwest Kansas counties. So next, I want to look a little bit more in our tornado genesis potential. So looking at the 0 to 3 kilometer mixed layer CAPE and surface vorticity, again, you can really see where that boundary is here. So this is going to extend a little bit into Pueblo's area. And you do have a little bit of overlay here of CAPE and vorticity. So this is a region where we really wanted to look for any potential tornadoes, whether they be landspouts or supercellular, as this frontal boundary continued to try to progress north. Over time, we do see this start to shift a little bit more to the east, so it's kind of straddling the state lines. And then as we move into the 1Z to 2Z time frame, you really start to see us lose that CAPE, and it's pretty much all just surface vorticity in that region. Looking at our lapse rates, we do have an area of lower lapse rates over northeast Colorado, which plays a big role, I think, in how these storms continue to cross that area. And then just along the boundary, we see still a pretty good gradient of lapse rates, with higher lapse rates just to the south in that drier sector, and then anywhere from 8 to 7 degree lapse rates here along the Cheyenne, Kit Carson areas. And this is going to again remain somewhat with the boundary and then progress east as we get closer to 0Z. And then it's going to start to expand to the northeast of those higher lapse rates while we maintain those cooler lapse rates around the Colorado, Wyoming, and then panhandle of Nebraska. Then here by the 3Z to 4Z time frame, you really see those higher lapse rates extend into north central Kansas and southern Nebraska. So now that we've looked at the SPC mesoscale imagery, I want to introduce some satellite images. So fortunately, during this event, we were located in both GO16 mesosectors. I have plotted this imagery in Google Earth Engine, which is going to overlay the satellite data onto a Google Maps interface. So the resolution may not be as clear as what we can get in AWIPS, but it works really good for a post-event analysis. So here I've highlighted a couple of features, and I did go backwards in time to the 1930 time frame, just so we can really see how this environment changed over time from the satellite view. So at 1930, you do see we have some ongoing convection here just east of Denver, and these are going to be located north of that frontal boundary. Just to the south of that boundary, we do see some developing cumulus clouds, which we are going to want to watch over the next couple of hours to see if they develop into storms as they remain in a more unstable environment. And then closer to our area, we notice these features here. So these are billow clouds. I have found a picture of what they look like from a plane view, so you can see they kind of look like a horizontal convective roll. And these are going to be caused by the ongoing storms and a potential gravity wave moving across the lee side of the Rockies. An important difference for these clouds is they're going to indicate a stable environment because they are perpendicular to the shear vector. So I have made a point to plot the low-level shear vector here so you can get an idea of how these storms are going to, or these clouds are going to show you that stable air mass. And so progressing forward in time, 30 minutes, again, we see these billow clouds remaining over Yuma County and into Flagler, and then a little bit further east. And you can kind of tell that these storms are moving into a more stable environment as they become more wispy along the leading edge of the anvils. And they're starting to lose a little bit of their convective punch. The frontal boundary remains somewhat stationary here across northern Cheyenne and across Lincoln County towards the Denver area. But just south of that frontal boundary, those developing cumulus clouds we were looking at have now developed into a strengthening storm that is developing supercell characteristics. Advancing 50 minutes later, you're going to notice that these billow clouds here, we do have the shear vector, so there is a little bit of a change in the shear. You have a little bit more of a southwest view here across Dundee into eastern Yuma, where in western Yuma, it's a little bit more south-southwest. And you can definitely tell that by how these clouds are orienting. Another change we see is we're starting to see some destabilization as the cirrus clouds over in our areas begin to clear on either side of that frontal boundary. And our storm is continuing to strengthen, and you can really tell it's starting to gather a bit of a punch. And at this time, it is beginning to produce hail. Looking into the 2215 time frame, so our storms here pretty much weakened fairly well as they move into that more stable air mass, which you can tell here it's very wispy as it moves across Yuma County. Not showing too many strong convective signs. You do have some bubbling up here from some stronger storms, but it's not a big looking severe threat like this storm here just to the south of that frontal boundary. So this is when the storm is moving into our CWA. This is an ongoing tornadic supercell moving across southwest Lincoln and southeast Lincoln into southwest Cheyenne. We do have some developing CU as that continuous clearing is allowing more destabilization to occur. So next I want to show you some radar images from this event. So this is going to cover when it ends our event to when the ending, when it's moving out and into Hastings and North Platte's area. So as we look at this radar imagery, you're going to notice these storms start off as discrete cells and then kind of coagulate into this MCS-like structure. And you can really see how that evolves by looking at the velocity. So as we look at it here again, we're going to start to see these velocities increase on the backside of the storm as that rear inflow jet descends down. And that's going to help push these storms a little bit further east and then more towards the northeast as they continue across. And as they reach this halfway point across Kit Carson County, you're really going to see that transition from a more tornadic, favorable storm setup to a strong wind and hail setup. So this storm along the leading edge is going to catch up to the line as that rear inflow pushes the storms ahead. And now you're starting to see that bowing out a little bit more, and that's going to bring in that wind threat. I also wanted to show you the mesh during this time frame. The mesh did really good during this event. Most of the time we did find reports verifying when we saw the 1-inch plots within the mesh product. So you can see we have some hail signatures initially, but those hail signatures really spike up around the midsection of Kit Carson County with that cell that was just out ahead of the band, and then that progresses east. Looking at the final half of the loop as the storms cross into Kansas and Nebraska, still see that good bowing structure with a strong rear inflow, pushing that along. And this is going to produce quite a bit of hail at this point, along with some strong winds. Looking at it with the mesh, so as these storms do move into Cheyenne County, right along the county line actually, we did receive a 3-inch hail report. And so that was the largest hail zone that we had received during this event. We do continue to see hail as it moves across St. Francis and then further to the northeast. And you can really see it by the reflectivity product, how this MCS is kind of rotating around itself as it moves across and then out of our area. With that where that stronger shear was located when we look back at the SPC mesoscale products. So to wrap up this event, I want to discuss our storm reports and verification. Looking at our storm reports and verification, we did have 39 reports. These were the not duplicated or corrected reports. And that includes 28 hail reports with damage. I did mark out this hail LSR. It is supposed to be in northern Kit Carson County, not southern. But our hail sizes ranged from 1/4 of an inch to 3 inches, with the largest hail reported here along the Yuma and St. Francis County line. Overall, we had 4 tornado reports. Now, granted, we did have quite a few reports sent in, and lots of photos and videos were found of the storms, but in order to condense that down to identify maybe the number of tornadoes that we have 4. Now, I do think, looking at the radar structure, especially the velocity signatures associated with that supercell as it moved into southwest Cheyenne, that was a supercell tornado and not technically a landspout. It would definitely be interesting to see if we had any stations there or any damage reports to kind of see what happened. Fortunately, we had no damage reported. One storm did move across US 40, and I want to say that one was a landspout tornado, but again, no damage was reported. It was pretty much all contained into fields. As the storms did move across the halfway point between Kit Carson and Cheyenne County, and we saw that evolution into more of a wind and hail threat, we did receive 6 reports of wind with some damage reported. I know along the St. Francis Yuma line, at the same property as a hailstone, he did mention a couple of trees were damaged on the property. And then, of course, a couple of other reports as you went across northwest Kansas and southwest Nebraska. Overall, we had 11 warnings issued, 6 of them verified, and we had a probability of detection of 88% and a false alarm rate of 45%. We did fairly good with this event, considering how slow it took to start, and then once it moved into our area, it just kind of advanced fairly quickly across. So we had an average lead time of just over 19 minutes. So again, everyone did a really good job, as we've seen mentioned by Jeremy and Ryan. And I hope you were able to take away something from this Storm of the Month overview. Let me know if you have any questions. Thank you for listening.